fourth graders, welcome to a very special fourth grade episode of How Many Tabs Are Open on Mr. Johnson's Computer? 1, 2, 3, 4, 5, 6. 6 tabs are open on my computer. On this window, we have hidden windows. Today, we are working on lines of symmetry. So let's go ahead and first things first, let's review some lines of symmetry. All right, so for instance, some shapes. Oh man, just thinking about that, just drawing a shape is not going to be that. It's not going to be that symmetrical. I wonder if I can use the shape tool. Let's try it. Um, if it's thinking. Okay. So there are some shapes that obviously are going to have, let's see, whoa, we can actually use a triangle for a lot of stuff. All right, so let's make some triangles, all right? And we're going to talk about lines of symmetry, all right? So some shapes have one line of symmetry. Some shapes have no lines of symmetry. Some shapes have like a lot of lines of symmetry. All right, so we're going to take a look at some of that right now. Okay, so first off, you can have vertical lines of symmetry. Okay, so a vertical line would mean you cut it vertically, up and down. All right, you can have horizontal lines of symmetry. So that means that you cut it from side to side. You can even have diagonal lines of symmetry. So that means that you can cut it diagonally. All right, so um, all of the shapes that you have on today's exercise can either be cut um, vertically, horizontal, or both vertically and horizontally. It looks like they're not actually even going to ask you about diagonal on this one. So that's cool. So we're not even going to worry about that. So we're going to look for vertical lines of symmetry, horizontal lines of symmetry. All right, so vertical, once again, up and down. Vertical lines of symmetry, you cut it in half this way and both sides match, or horizontal lines of symmetry. All right, so what I mean by that is if we took this triangle right here and we cut it in half vertically, oop, sorry, my line's not going to look very pretty, but we're going to just pretend that's a straight line and Mr. Johnson can draw straight lines. If we cut that in half and we just folded it on top of each other, it would completely match, all right? So that has a vertical line of symmetry. Okay. This triangle also has a vertical line of symmetry, but because this triangle is equilateral, I'm just going to show you something real quick. You could also have those diagonal lines of symmetry that I was talking about. Basically, if you folded it diagonally as well, like you could fold this triangle basically three different places. So you have three different lines of symmetry. One is diagonal. All right. Just trying to think. So sometimes you have vertical lines of symmetry. Sometimes you have horizontal lines of symmetry. So let's say if we just had a square, and once again, I'm not drawing the most perfect thing, so my symmetry is not going to be perfect. You could not only cut it vertically, and then it would match up on both sides. But you could also cut it horizontally and it would match up on both sides if you folded it that way. So basically what we're doing is we're just in our brains, we're folding shapes and letters. And if it matches up perfectly on the fold, then you have a line of symmetry. For instance, let's take the letter A. So we're taking every letter of the alphabet and we're finding out if it has a vertical line of symmetry, a horizontal line of symmetry, both vertical and horizontal, or no symmetry at all. So let's take a look at A. A has a vertical line of symmetry. If we look at the letter A, we can cut it this way and fold it on top of each other and it will match. We cannot cut it vertically because if we folded it on top, this small triangle part would be basically like that, right? So we have a vertical line of symmetry because if we cut it up and down, then it would match up on both sides. So that's why we're putting it in the vertical line of symmetry. B, on the other hand, is the opposite, right? It's got a horizontal line of symmetry. If you think about it, I'm going to try and once again draw this as perfect as possible, but it's not going to be perfect because I am not a robot. I am not a robot. It's something a robot might say. So if I cut this horizontally, the two like lumps on the B should fold and cover each other up. Once again, I didn't draw a perfect B because I'm not perfect. But if we cut it there, that's where it would match up. If we cut it vertically, it's not going to match up because we have curves on this side and we have a straight line on this side. So if we folded it in half side to side, it's not going to match up. So B only has a horizontal line of symmetry. It's the one that goes in the middle. All right. So let's take a look at some of the other ones. C. Can we fold C in half vertically? No, if we folded it in half vertically, one side is open, one side is closed. If we folded it in half horizontally, we would still have the same line of symmetry, right? Once again, with the letter C, if it was perfect, if I cut it like this, those two sides will match up when we fold it, right? If I cut it with the vertical, when I fold it, this side is open and this side is closed. So that is not going to match up at all right? So um, as you work through these, all right, go ahead and like pause your video and then I'll go ahead and put all the right answers in here so you can check your work afterwards. But pause it. That way you can test yourself and see if you know where the lines of symmetry are. All right. So pause and then come back and it'll be basically you can check your answers then. All right, so D, if we cut it in the middle horizontally, it will fold over on itself, and that will make a line of symmetry. E, same thing. If we cut it in the middle horizontally from side to side, the top and the bottom will match up. F, no line of symmetry. If I cut it vertically, so let me show you all that one. F, if I cut it vertically, right, there's no line on this side. It will not match up. If I cut it horizontally, there's no line here and there's a line here, so it will not match up. So there are no lines of symmetry on F. On G, once again, it's got that odd little part right there. So if we fold it in half vertically, we have a tail on one side and not the other, and we have an opening on one side and not the other. If we fold it in half horizontally, we still have that piece that's hanging over. So no line of symmetry in G. H is actually one of those ones that we could fold both ways. So if we take a look at H, not only can we cut it in half horizontally and the top and the bottom match up, but we could also cut it in half vertically and the sides would match up completely. So that's got both vertical and horizontal lines of symmetry. Same thing with I. Cutting I in half vertically is hard to imagine, but just imagine you split it directly in the middle. So half of I is on top of the other half of the I. J, we have no lines of symmetry. If we cut it in half this way, we have a loop on that side. If we cut it in half this way, we're missing a side over here. K, in this situation, this K has no lines of symmetry. Depends on how you draw your Ks, but this one, since those lines do not match up evenly on the right side, then it cannot be cut in half down the middle. All right. L, another one of those situations where we have a lot on one side and not a lot on the other side. We have a lot on the bottom, but not a lot on top. So if you fold it either way, it would not match on both sides. M, we can cut that down the middle vertically and fold it upon itself, and it'll match up perfectly. All right. N kind of looks like it would, but if you think about it, when we fold an N in half, part of that middle part is going to be on the bottom, and part of that middle part is going to be on the top. So that's not going to line up. O, oh, I put the M in the wrong place. That was vertical. That's totally my bad. M is vertical. There we go. Okay. Oh, that definitely has both lines of symmetry. You can cut it in half this way. You can cut it in half vertically, horizontally. It does not matter. You will have the O overlap horizontally. You will have the O overlap vertically. All right. P is another one of those letters that is lopsided. It's got a lot going on one side and on the top, but it does not have a lot going on the other side. So if we folded that, it would not match up. If we folded that horizontally, it would not match up. Same thing with Q. Since it only has the tail on one side, it will not match up if we cut it vertically. R is much like P. It's got a lot going on one side and only a straight line going on the other. We cannot fold it on the vertical axis. All right, S. S is one of those tricky ones too. S looks like it would work if you cut it in the middle, but the loop from the top part would actually be on the empty side over here. So it would not match up or vertically or horizontally. This one is no line of symmetry. T, we can definitely slice that T in half vertically, and it will fold over on itself, and it will match on both sides. Same thing with a lot of these letters at the end here. A U is symmetrical vertically because if we folded it in the middle like this, both sides would touch and overlap perfectly. And if that works for U, that also works for V, that also works for W, because if you fold a V in half, it's overlapping. If you fold a W in half, it's overlapping. Got a couple more letters. My big head's in the way. All right, X. X has both, right? Both a horizontal, as far as if I cut it in half this way, the top and the bottom will match, and a vertical. If I cut it in half sideways, the two sides will match when we fold it over. Same thing happens for Y with the vertical line of symmetry, because it's the same on the left side as it is on the right side. If you folded it over, it would match. And then finally, if we cut the Z in half, once again, it's kind of like the S. It looks like it would work, but you're going to get like a backwards version of the top half when you fold it over. All right. So the corner would be on the right side on the top, and the corner would be on the left side on the bottom. So there's our letters. Go ahead and check them. Let's move on. Next one. Which of these figures appear to have both a horizontal line of symmetry and a vertical line of symmetry? All right. So horizontal, L is already out. If I cut this one sideways, let me just put some lines in here. If I cut this sideways, obviously there's no arrow on this side, right? How about over here? If I cut this one vertically, looks good. It would match up. If I cut this one horizontally, also looks good, like it'll match up, right? The top and the bottom would match, and the left and the right would match. All right, so if I cut figure N in half vertically, will it match up? Will this arrow side match up with this square side over here? No. So this does not have both lines of symmetry. This one actually does have a horizontal line of symmetry. If we cut it horizontally, yeah, it definitely would have the same shape on both the top and the bottom if we folded that over. One more to look at. Let's look at this last one. If we cut it on the horizontal axis, yeah, all my lines are not that straight, but if we cut it on the horizontal axis, the top and the bottom will match up. And if we cut it on the vertical axis, the left and the right will match up as well. Sorry, my lines are not perfectly straight. That's not helpful. All right, so the top and the bottom would match up, and the left and the right would match up if we cut these in half where those lines are. All right, so it looks like figure M had both a vertical and horizontal line of symmetry, and figure P had your vertical and your horizontal line of symmetry. So is there an answer that says figure M and P? Yeah, right there. C. M and P only. All right. Moving on, moving on. We got a couple more pages. Okay. Which shape below does not have a line of symmetry? Decide how many lines of symmetry the other shapes have. All right. So one of these is obviously not going to have a line of symmetry because it says up here which shape does not have a line of symmetry. Well, let's go ahead and figure out the ones that do. If we slice this smiley face in half vertically and fold it upon itself, is it going to look the same? Yeah. If we slice it in half horizontally, nope, the eyeballs are going to touch the mouth. All right, that's not going to look the same. So how many lines of symmetry? If we only have a vertical, one line of symmetry. I just hit the microphone, sorry about that. All right, next one. This one actually has a lot of lines of symmetry, but we weren't talking about diagonal today, so we're just going to go with our vertical and our horizontal. But if you think about it, could we cut this sun? Oh, wait a minute. No, we couldn't do it diagonally because this is an oval. That's not a circle. So there we go. We have two ways that we can cut this. We can cut it down the middle. And as you can see, this side will touch this side will touch this side will touch this side, and these will just be halved. So it will absolutely cut on the vertical axis. If we cut it along the horizontal axis, it will do the same thing. Remember, you have a line tool, so if it helps you to just like make the cuts yourself, you can kind of see. Oops, let me redo that one. Started in a bad place. Okay, so and then if I do that, why doesn't it? I just messed up again. This is fun. All right, here we go. One more time. Okay, so as you can see, you can cut it vertically, you can cut it horizontally. This one actually has two lines of symmetry. All right, the heart, we can indeed cut the heart in half vertically and get those two sides to match up, but we cannot cut the heart in half horizontally because there's bigger pieces up here that would overlap on this side, right? So that's not going to be symmetrical horizontally, but it will be symmetrical vertically. All right, that leaves us with this cloud. All right, and the reason why I can look in this cloud and know that it's not symmetrical is number one, this little line right here. Does it have a matching line anywhere on the left side or anywhere on the top? No. So this little line kind of gives it away. We can't fold it. This line doesn't have anywhere to match up on this cloud. All right, so none. So the cloud has no lines of symmetry. The smiley face has one. The sun has two, and the heart has one. All right, final page. So I'm gonna go ahead and once again, if you pause right now, you can check your work with mine, and then that way you can feel confident that you've got this on your own. All right. So I will go over this, but the best thing to do right now is pause and then just like kind of test yourself. All right, and see if your answers match the answers that we come up with when you come back. All right. So let's go ahead, and if you are feeling confident, I want you to go ahead and pause and then press play when you're done sorting all of these. All right. Okie doke. So we're gonna start off with zero lines of symmetry. All right. Any shape that just kind of looks like it doesn't have anywhere where you can fold it, we're just gonna like at least horizontally and vertically. All right. For now, I know that some of these can be folded diagonally. Like we could fold this one diagonally, but it's not part of your assignment. All of your assignment stuff says horizontally or vertically. So just remember that like in real life you can cut things like diagonally. So in fact, let's see. Yeah, we're gonna go ahead and not do diagonal for this exercise because you have an area that says zero lines of symmetry. And there's not many on here. Actually, there are some on here that have zero lines of symmetry. So we're gonna do diagonal. All right. So if I cut this shape right here a little bit diagonally, will that fold over on itself and match? If you said yes, yeah, it will. So it's got one line of symmetry. It's just gonna be if we cut it right there, then it should fold over on itself. Same thing goes for this one. If we cut it diagonally this way, it should fold over on itself and be symmetrical. All right, this one looks like it has one line, two lines, three lines, four lines. If we cut diagonally, we actually have four lines of symmetry on this one because we can cut diagonally this way, cut diagonally this way, we can cut vertically this way, or horizontally this way. So four or more. All right, on this shape, because we have this odd line hanging out here, if I cut it vertically, it's not going to match up because one side's going to be taller than the other. If I cut it horizontally, it's not going to match up because this line is at a slant and this line is straight. So this actually has no lines of symmetry, even though it has a set of parallel lines. All right. This one, we can cut it vertically, we can cut it horizontally, and we can even cut it diagonally and it should match up. All right, so we can cut it diagonally twice as well. So this one should have four lines of symmetry. So if you could see yourself like cutting it this way, this way, this way, and this way, then that's gonna have your four lines of symmetry. All right, this triangle, it does not look equilateral. It looks like the bottom line is longer than the side line. So this is only gonna have a vertical line of symmetry. We can slice it vertically and it'll fold over on itself. But since this bottom line is larger than these two side lines, we can't do those diagonal ones. We can't do the three lines of symmetry. If that is an equilateral triangle, and it's hard to tell on this. If it was an equilateral triangle, you could definitely do three lines of symmetry because you could cut it diagonally, diagonally, and vertically, right? This shape, this little corner messes it all up because this little corner doesn't exist over here. This side's curved, this side's flat. It cannot be folded vertically or horizontally. We have zero lines of symmetry. All right, let's look for some more ones with zero lines of symmetry. This one, if I cut it vertically, it's not going to match up. If I cut it horizontally, it's not going to match up. So we do, in fact, have zero lines of symmetry showing up. All right. On our oval right here, we can cut it vertically. We can cut it horizontally. All right. If it was a circle, we could cut it every single way we wanted to, and it would be symmetrical. All right. This little kind of diamond pattern, it looks like we can cut it vertically. We can cut it horizontally, and we can also cut it diagonally both ways. So that should make four lines of symmetry. This triangle, once again, it's not equilateral. All the sides aren't even. So it looks like we can only cut it vertically for it to match up on both sides. So that's one line of symmetry. All right, this shape over here, it's got like the right side and the left side look different. The top side and the bottom side are definitely different. So we cannot cut this one. It's also not exactly the same length right here as it is over here. So we couldn't even cut it diagonally. If it was the same length on this side as it is this side, we might have been able to cut that one diagonally. All right, another one we can do is we can cut this one in the middle, right? So things about this one, you can cut it down the middle, you could cut it down the side, and even can we? Let's figure it out. Can we cut it this way? Oops, that's not right. Let me move it. Oh, let me just delete that. Can we cut it diagonally and it still match up? Can Mr. Johnson even make a diagonal cut without messing up? That's another good question. All right, I'm having trouble moving this thing, but if we cut it like that, will those sides match up? Strangely, yeah. So this is another one where we could say we have four lines of symmetry. All right, get rid of all my lines over here. All right, so this shape right here, oh no, I messed it up. Did I mess it up? Oh no, that's just the way it is. Okay, so this shape right here, obviously vertically cutting it's not going to work, horizontally cutting it's not going to work, but a diagonal cut might work. If we cut it diagonally, I bet we could make this side over here and this side over here match. This shape right here, we can cut it vertically, horizontally, or diagonally, and it'll match. So that's four lines of symmetry. Star shape. If we cut a star shape vertically, it works. If we cut it horizontally, it does not work. So we're going to say that one has one line of symmetry. We could cut it diagonally too, though. So let's think about this. If you can cut it in half this way, you can also cut it in half this way, and you can also cut it in half this way, and you can also cut it in half. Okay, so I think I broke this. I think I broke it because there's four, and then we can cut it in half one more way. That would be five. Oh, four or more. That's or more. All right, so our star can actually be cut all the ways. Um, because if you think about it, when you cut that star vertically, just turn the star a little bit, right? If you turn the star and put the next point up, it would be exactly the same, right? So you could basically cut it on every point, and that would cut it in half. So it would be symmetrical. All right, this pentagon five-sided, If we drew a line vertically, this side would touch this side perfectly. So that's one line. If we did the horizontal line, this has a point and this is flat, so that would not work. All right, this one, two lines of symmetry. If we cut it in the middle, yes. If we cut it in the middle horizontally, also it would match up. Same thing with this one. If we cut it in the middle, if we cut it to the side, um, we have a 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. This is an octagon, so we can cut it in the middle, cut it horizontally, vertically. You could even cut it diagonally. So that has more than four. All right, this star pattern we could cut vertically, we could cut horizontally, and it's a little stretched out, so we might not be able to cut it diagonally and it match up. So we'll go ahead and say that this one has the two lines. This one, we can cut it horizontally and we can cut it vertically. So that would match up. You could also cut it diagonally, and those diagonal sides should match up as well. So we could say that this one has four more. All right, since we have nothing in three, I'm beginning to think that this was an equilateral triangle. All right, so let me show you one more time why there's three on this one. If this is an equilateral, there's one cut, that would work. We could also do a diagonal cut this way. That would also make those two sides match up. And then if we did a diagonal cut this way, that should make these two sides match up. All right, so I'm assuming that because of the fact they gave you a spot for three lines of symmetry, oh no, I just messed that up majorly, and we don't have anything in that spot, probably means that we need to put that triangle right there, probably an equilateral triangle. So there are your places, your lines of symmetry where everything can go. So hopefully the diagonal stuff counts. That's the only way I could see you having some of these things, like three lines of symmetry was counting those diagonals. So remember, symmetry can happen horizontally, vertically, even diagonally. All right. Okay. Well, I hope that helps. I hope that you are having success on your assignments. And I guess if you need any help, reach out to your teachers. And I hope you have a good day. Like and subscribe if you feel like it. And I will talk to you later. Have a good day. Bye.